Good morning, everybody. Welcome to the session number 2 of our Pro Summit. My name is Felipe Castañeda, Creative Director here at MakerBot. And today we'll be joining by Shaper 3D, specifically by Istvan Chesnadi. I'm hoping that I'm getting that correctly. And give me 1 second. And Peter Cox. They'll be showing us how to use their software. As you guys probably have heard and seen a lot of it. Shaper 3D is live, I would say pretty dynamic software, intuitive for specifically designed for iPad and Apple Pencil. And having used it for a few weeks now myself, rather compelling, and I'm sure they'll have much more to say about it. So welcome, Istvan, and welcome, Peter. We're really glad to have you guys this morning with us.
Hey, Felipe. Thanks for having us. It's a pleasure to be here. And today I will give you a quick overview of who we are and what we do, and then I will hand it over to my colleague Peter, who will give you a quick demo of Shaper 3D. So we started Shaper 3D because we think that there is a huge opportunity in reinventing basically 3D CAD for 2021. Because if you look at the traditional CAD systems, those tools are amazing and they have been serving us incredibly well over the last few decades, actually. But they were invented for a different world, for the needs of the 1990s, and not much has changed in the world of CAD since then, despite the entire world has changed. The way how we work has changed, the kind of computers we prefer to use has changed. The way how we prefer to learn and buy software has completely changed. Pretty much everything has changed except CAD, and we think that there's a huge opportunity in just rebuilding CAD from scratch, or almost from scratch, for this completely different world. And one of the so we are changing quite a few things when it comes to CAD, and one of them is how accessible CAD is. So Shaper 3D was indeed designed for the iPad, and it was indeed designed for iPad and Apple Pencil. That allowed us to question really every aspect of how you can interact with your 3D design. But we recently introduced Shaper 3D for Mac, and Shaper 3D for Windows is also on its way. We put quite a lot of effort into interaction design. Sorry, I'm having a technical issue here with my screen sharing. So I will just switch to a regular view. So we worked a lot on making Shaper 3D much more accessible than traditional software, and that means that that helped us a lot with giving access to professional 3D design to audiences that previously were not necessarily professional CAD designers, but were very closely with CAD designers. And also we have a lot of customers who are professional CAD designers and using Shaper 3D as an extension to their tool chain. What we did not compromise with is robustness. Shaper 3D is built on Parasolid, which is the industry standard CAD engine. It's the same engine that the market leading desktop CAD systems are using. So that means that the quality of the geometry that you can create with Shaper 3D is basically the same quality of geometry that you would create with any other Parasolid-based CAD system. It's just the way how you're interacting with these designs is different. And of course, it also means that we are export and import compatible with other CAD systems, since the data representation in Shaper 3D is the same as in these CAD systems. We are just as compatible with other CAD systems as other CAD systems are compatible with each other. Also, these models are not just nice piece of what's created with Shaper 3D is not just nice piece of graphic. These are actual industrial grade manufacturable solid models. Thanks to Paris Solid, you can export these designs to a really detailed, high quality STL5 format, and using the power of direct modeling, you can also edit solid models in Shaper 3D that you are importing from other CAD systems. As of today, we have more than 27,000 customers, and the majority of our customers are using Shaper 3D for business. And not surprisingly, they are very often using Shaper 3D for 3D printing. And these customers are very often using MakerBot 3D printers. Actually, we see that a lot. And we offer 3 different pricing tiers for our customers. We have a standard tier and a business tier, and we have a special offer today for the attendees of this conference. We are giving you 30% off from the first year of your subscription if you use the MakerBot 10 coupon code on our website. And of course, the same subscription can be used on every platform that we support. So if you buy a subscription, then you can use Shaper 3D on iPad, Mac, and very soon on Windows as well. So thanks for listening, and I will hand it over to Peter now.
So now we're jumping to the second part. Thank you so much, Istvan, and thank you especially for that nice promo code. 30% is quite a bit. I would highly recommend anybody who's curious or just want to know it, like just get the trial and like get started on it. I've used it, as I said, for a few weeks, and especially like the first couple of hours. I think what impressed me the most was how easy it was and intuitive it was to use, you know, having no real background in the, I guess, designing in 3D in an iPad. That was kind of a whole new experience. You know, I have a background in industrial design, but I've never done it in a tablet device, and it was incredibly easy to get started. So I'll highly encourage everybody to jump in and test out the platform. And then for the second section of our webinar today, Peter is going to take us through the process of designing specifically robot end effector. We'll go through the whole process of making it in Shaper and then exporting it for the printer, in this case method, to be printing it. So I'll leave it to you, Peter. Thank you for joining us today as well. And yeah, let's keep going.
I'm going to show you how to create this vacuum gripper in Shaper 3D in the following few minutes. Now you will see red dots that will represent where I touch with my fingers, and you will see pencil shape where I touch with my pencil. Let's jump into a new workspace. When you open up a Shaper 3D design, you will see that you can import the most common CAD formats like STEP or IGES or XT, or you can start with an empty Shaper 3D design, as I will do now. The basic shape of this gripper is a simple triangle. So I'm going to start with a triangular polygon centered from the coordinate system of our workspace. And after constraining and dimensioning this triangle, I can move on to the cross-section of the vertical channels, which will be a simple circular shape with a 2 mm radius. Then let me do a second one. And then I will need one more reference that connects the 2 circles together. After rotating away the view, you can see that the enclosed areas are highlighted with blue. That means you can interact with those cross sections. I will do the same. I will select the circle from the picker end and extrude it downwards by 18 mm. Then I'm going to select the vacuum inlet end and extrude it upwards by 18 mm. There I have the 2 vertical cross sections. I will need to connect those together with a horizontal section. But to do that, I will need to define a construction plane that is perpendicular to the line that connects the 2 circles. After making sure that the plane is perpendicular to the line, I will need one more reference, which is one side projected to the plane. There I have all the references, and I can move on by creating the cross-section of the horizontal channel, which will be a pentagonal polygon to make sure that I will not need any support in the channel itself. And after constraining this pentagonal shape and dimensioning it, I can zoom out a bit and rotate away the view to extrude it to connect the two vertical channels. But as you can see, it cuts into the other channel, which is the intended use of shaper. In this case, we can change it anytime by tapping on that blue icon and tell it to create a new body. And there are two small problems with these models, which I can solve easily by selecting the picker end and moving it upwards by 3 millimeter, and selecting the inlet end by moving it downwards by 3 millimeter. There I have the solid bodies that I can work on in the following. So let me just clean up the workspace by removing the sketches and the plane. And I can simply just array these bodies to get this triangular shape. Let me select the bodies and move the pivot point to the center of the coordinate system and rotate away by 120 degrees once. Adjust the view a bit, and then rotate away the body again by 120 degrees to have the clear triangle shape. There I have all the bodies to form that vacuum channel. I will merge them together with the Union tool from the left side toolbar. And I have one single solid body with a detail that I quite don't like. That blob should be moved away. So I'm gonna select the two faces and replace the lower with the bottom of the pentagonal shape to have a clearer shape. And I have the finished channel shapes in my workspace. Now I need to create a bigger piece of body that I can cut the channels out of. This body can be a simple rectangular shape around it. The main goal is to make it slightly bigger than the channels. I'm gonna extrude it upwards by 26 millimeters. And as you can see, it automatically cuts into the channel shape. So I'm gonna choose to create a new body and move it downwards by 13 millimeters to make sure that the channels are aligned in the exact midplane of this box shape. The sketch will not be needed, so I'm gonna remove it. And by selecting the box shape and the channels, I can subtract them from each other to get the channels cut into this big piece of material. To shrink it down, I'm gonna use a shell tool from the outside. To do that, I'm gonna select all the 6 planar faces of this box shape, and then select the shell tool from the toolbar on the left, and define a wall thickness of like 3 millimeters. There you can see we have a pretty sleek design with just as material as it's necessary to have the gripper working, but it lacks some mounting points. So I'm gonna do that next on the bottom face of this gripper. I will need one more reference, which will be a circle that is concentric to one arc of the edges. And I will create a second rectangle in my workspace. After defining and constraining this rectangle to be 45 millimeter long and horizontal, that line, I can extrude it upwards. And in this case, I'm looking to create a 3 millimeter extrusion that merge together into the channel with the channels. So I'm gonna select Union, and I have that flat shape with pretty sharp edges. So let me select these 3 edges and apply some chamfer or more than a fillet on them. A 6 millimeter fillet will be perfectly fine for me now. Then I can move on with the screw domes. The domes will be simple cylindrical shapes defined on the top surface of this planar body. They should be concentric with the filleted edge with a 3.5 millimeter radius. And I can extrude those upwards by 20 millimeters. There I have the screw domes, and I will need a cut-through hole for my M4 screws So I'm gonna create another circle on the top face of that dome, constrain it to be concentric with the edge of the dome, and define a radius of 2.1 millimeter. Extrude in a way the cross-section results in a cut-through hole. And this is exactly what I was looking for in this case. Let me add some material by applying a chamfer at the corner, and then I can start to array this body. As you can see on the left side, based on my selection, the toolbar changes a lot. In this case, I'm gonna select the faces of this screw dome one by one. And there you can see that the toolbar changes, and I will select the Move Rotate tool, move the pivot point to the center of the coordinate system, and array it by 120 degrees, and array the body once again by 120 degrees. There I have all the 3 screw domes that I was looking for, and I can move on to some alignment. But before doing that, let me clean up the workspace again and import some reference parts to make sure that there will be no interference between the construction parts and the mounted parts. As you can see, you can import step or edges in the workspace. I have a prepared Shaper 3D workspace here with the vacuum parts and the end of the robotic arm. Let me start with the vacuum inlet connector. I'm gonna use the Align tool to align those 2 selected edges together. After applying the tool, you can see that the body is flipped, but I can flip it anytime back by tapping on that small blue icon. I hit done, and let's move on to the picking point. I'm selecting the 2 edges to align, then hit the Align tool. Let's do it one more on the second picker. I want to align this edge to that edge, and hit the Align tool and flip it because it's oriented in the wrong way. And then I can move on to the third one by selecting the 2 edges. And there you can see on the left side, I can tap on the Align button and finish the tool by hitting the Done button. There I have the printed part and the reference parts. Now I have to connect them to the robotic arm. I will design a bracket in the next few steps that will be placed on the top surface of the screw dome. The main shapes that define this bracket will be 3 circles placed on the exact midpoint of the screw domes. And after locking those together and constraining the radius to be equal on these 3 circles, I will set one radius to be 6 millimeter. Then I will need a 4th circle, to make sure that I will have enough clearance in the workspace between the parts. And then I will need a 5th circle to make sure that I will have enough material thickness. I will need to create a small handle shape to this part. So let me just create 2 lines, constrain those to be symmetrical to a vertical edge, constrain them to be vertical by themselves, connect them and define the distance between these 2 lines. And then I can rotate away the view again, and I have a lot of cross-section to work with. After selecting these cross-sections that I'm looking to extrude, I can select those and extrude upwards by 3 millimeter, and I'm looking to create a new body, as this body may not be 3D printed in each cases. It is perfectly fine if it's laser cut, for example. The shape is almost ready, but the handle is quite short, so let me make it longer by moving that face by 70 millimeter. And then we have arrived to the 3rd part that is designed in the workspace. The orange parts on the robotic arm are standard parts published by the manufacturer of the robotic arm to make sure that 3rd-party manufacturers are able to create accessories for their robotic arms. I will use that cylindrical shape as a reference in the following. Let me just hide the robotic arm because it will cover my view, and I'm going to draw a sketch on that tiny planar face. It will be a simple circle with a 20mm radius. And after rotating away the view and extruding it to get a small disc shape, I will turn back on the robotic arm, and there you can see that the reference has the exact same dimension that I created, which is fine, but from the alignment, it is not that optimal. So let me just select the outer edge of this disc shape that I just created and offset it out by 5mm. And extrude backwards the enclosed area. There I have two simple bodies that I will join together by the union tool. And you can see that I have that small shoulder shape there, which is what I was looking for. It helps a lot in the alignment. Let me just make it a bit more user-friendly by applying a chamfer there and a 1mm chamfer on the inside to make assembly easier. And I can move on to create the screw holes. Holes will be created by simply just selecting them and projecting those to the face of the lastly created part. And after I have the 4 cross sections there, I can simply just select them and extrude away the material to have the holes for the screws, and I can assemble the robotic arm with my gripper pieces. Let me just align the arm to the gripper assembly to make sure that we have enough clearance and the holes are perfectly placed. From the side, there is enough clearance. From the hole perspective, yeah, the holes are aligned fine. We can move on to manufacturing, but before doing that, let me just clean up the workspace again. And let's create a printable file from the gripper. To do that, we need to hide every other part from the workspace. In this case, like the robotic arm and the 2 parts that will now be 3D printed and the machine parts, and I can hit the export button. As you can see, it is possible to export into the most common CAD file formats. We can create augmented reality in Shaper 3D. It is possible to export technical documentations, or image export is also possible, and we can export in sketches. Or you can back up your design in a Shaper 3D design. But in this case, I'm looking to create a 3D printable STL file from this gripper. After naming this file, I can hit continue, and as you can see, the mesh conversion happens in a few seconds, and the file is ready to be sent to a 3D printing machine or any facility. The workflow is a bit more different if we are looking to machine the parts, because apart from having the step where I just export, we may need to provide technical documentation of the part. Let me just create a drawing of the selected part by tapping on the Create Drawing button on the left. And after selecting the sheet size and defining the sheet scale, I can move on with the tab, and there you can see all the projections are made in a few seconds. And I can easily define the bonding dimensions of the workpiece. I can align those dimensions if I wish to. Let's measure a total width of the part and measure a material thickness. There we have the drawing which I was looking to create. I can export it in a DWG or a DXF format, or even a PDF, which makes it possible to print the drawing directly from the iPad. And this way I do not have to jump back to my desktop PC to print out the blueprint. You can do that on the go. This was all from me today. Thank you for joining us, and let me handle this to Felipe. Thanks.
Right. Thank you, Peter. Really impressive, actually, and incredibly fast the way that you model that end effector. So, after you've modeled that end effector, the idea here is how do you actually map it to a physical part, right? That having that quick and fast interaction. So what I'm going to do now is take Peter's file. Let me just share my screen in just a second. But take Peter's file and import it into our cloud-based platform as well. So as you know, very similarly than what we saw just now with Shaper 3D, we at MakerBot, we're also based basing our slicing software in the cloud. That essentially means that you're able to upload your files, connect to your printers, and manage all of your printing preferences through the cloud digitally without consuming any local resources on your computer, which I think is pretty awesome. And essentially, what I can do once, or with Peter's model here, once it's done, just import it to my print bed. In this case, I'm connecting to my local MethodX here. It's loaded with ABS, as you can see here. Well, I'll just take you guys through the interface real quick. So showing my printer. So this is a printer that I'm connected to locally here, loaded with ABS as the model material, SR30 as our soluble support material. And now here in my build plate, the representation of Peter's part, right? I can go ahead and quickly select one or the other, balanced or solid mode for print settings. If I wanted to further customize the settings, there's over 2,000 settings that I can change here, from the base layer, the infill density, the type of support that I'm going to be using, and even more. So, you can go into quite a lot of detail here, selecting the, changes in the roof settings, changes in the number of shells, the speed of the shells, the different temperatures for the extruders, quite a lot of control there. Now, I would recommend, especially if you're guys just getting started with the printer, to stay within the defaults. Those have been thoroughly tested by our engineering teams and essentially work really well with the method and with the material combinations that we offer. And once you've selected either one, so balance is going to give you like a nice in between with about 20% infill, straightforward printing process, pretty good balance between the time that it'll take for your part to be printed out and the actual sturdiness of the part. Or if you want a fully solid part, you can just toggle the solid button here, and that'll essentially create and print a part that is pretty much solid once it comes out of the printer, right? You can also hit print preview here on the top right corner. That's going to essentially start the slicing process. Again, this is also done in the cloud, so there's no local resources being consumed. And in turn, you can just go ahead and keep working on other projects if you wanted to for those, I don't know, like 30 seconds that it'll take for the rendering and the slicing process to be done. And as you can see here, now my part has turned blue and it's showing me these gray areas, which are, well, the supports that are going to be, the supports that are going to be generated by the printer as it prints, right? As we know, any components of the part that are not self-supported will need something to stop or to land onto as they are printed. So that's where we're using supports. And in Method's case, you're able to use soluble materials for the supports, which means you'll print the part, you'll get the part out, wash away those supports, and get the part, for you to use. Pretty straightforward process. Once I'm done and I'm happy with the pre-render, I can just go ahead and hit Q here. That'll send the part and the job to my printer. As you can see here now, ShaperBot STL is loaded for my printer, and I can just hit Start Next Print. Start the print is just confirming that I'm selecting the right printer for the job. I'll go ahead and hit Start Print. And if I jump back here to my main view, it should take just a few seconds for the printing process to get started. Once it starts, I'll let it run and we'll get into the Q&A section. Here we go. So the build plate is raising up. Now the temperature is going to be rising in the printer itself. It's going to go up to 110 degrees Celsius because we're printing in ABS. And that's pretty much it, right? After that, it comes the back and forth of, once I have my part printed out with me, just basically essentially talking, let's say that Peter was my engineering team, my design team, what are the changes that we would want to do on the part? How do we improve it? Even testing it out, seeing that everything is fitting nicely and appropriately. Since this is an actual holder, maybe making sure that the pipes are big enough, that the airflow is not leaking and flowing accordingly to what we expect. And basically closing up the loop. And if there's any changes to be done or needed to be done, just get started back again in Shaper, make any changes. And the cool thing about Shaper, and you can correct me if I'm wrong here, Peter, but is that since it's basically a parametric software, you can make any changes later on. Let's say that you wanted to increase the diameter, increase the sizes of your part, and very easily make alterations to your part depending on how it's performing and any sort of updates that you would want to run. once you have the printed part with you.
So if I don't like any dimensions, I can simply just select the face and directly interact with it. This is why is it called direct modeling. Like if I have an imported part, even the robotic arm, there I can select the face and move it to meet the desired dimension, or I can move or change the radius, or add some chamfers or fillets. So yeah, I can directly interact with the model.
I think that what that just happened is, I think it's part of what makes it so intuitive, at least for me. I don't know if you guys saw, but how easily it was for you to change between the fillet and the chamfer and that operation that you were just doing just now. I think it's, I don't know, incredibly responsive, at least from what I've experienced so far in using different types of software. In particular, this like sort of reacts very fast to your intention, if that's, you know, one way to describe it.
Yeah. I'm in totally love with that software. You know, it's so fast to use. You can create design, as you could see in the video, in just a few seconds. So yeah. What else should I say when you saw what can be the result?
I was wondering about, like, now that you were mentioning about the imported part, you know, what are the files that are compatible that you can bring into Shaper and just start editing after, or, you know, within your...
As we are based on Parasolid, we are supporting the default Parasolid XState format, and you can work with step or IGES files. These are the most common CAD file formats. You can import them and edit those, just I did before. We are supporting mesh file formats like STL or OBJ, but as a CAD modeling software, we have a restricted editability of these files. And you can import or export in DWG or DXF if you wish to model or work with two-dimensional file content.
Yeah, actually, that's, you know, good for you to mention. That was the actual type of file that we used here. We exported your original part in STL. That also makes it a little bit lighter. So essentially a mesh-based polygon representation, and that's what we're using for the printing process. You know, with that, I'll start jumping into the questions. So if anybody has questions, we have already several of them coming in. Feel free to add them to our chat there. You see the chat box, and Alejandra is going to be collecting all of them and bringing them up to us as we go. So first question, could you show how you would change the wall thickness of those tubes? So for example, you defined it as 3 millimeter. If you wanted to make them bigger or smaller, how hard would that be?
In this case, it would be easier to do in a step when the model is not ready yet, because let's say I'm gonna move this body away, and I can redimension any circular face by grabbing the perimeter and moving this. So I can make this hole smaller by selecting only that hole and making it, let's say, 1.5 millimeter. To change the whole wall thickness of the gripper is not what I would do in this case, because it is so complex with this face and all the mounting points that it would break the model. And as we are solid body modeling software, all the models that you create in Shaper 3D are perfectly manufacturable. If you would allow that operation that would, let's say, split up the solid body model into surface elements, it would not be manufacturable anymore. So we currently do not support yet.
Yeah, and I think that that's something that I remember the first couple of times, well, back in the day when I started modeling in 3D, how easy it was for you to generate pseudo solids that were not completely closed. So if you wanted to print them out, they would have holes on them, or they would simply not print. You know, the slicer would just break because you're trying to export a series of surfaces that on the render might look like a solid, but it's just, you know, basically patches here and there instead of like a completely solid body.
Absolutely.
Next question here. So what are the largest dimensions of a 3D printing part? Is it possible to print? Oh, okay, I guess these would be for the printer itself. So what are the largest dimension of a 3D printing part? Is it possible to print 4 inches in diameter? by 36 inches part. So specifically on the method, the build volume is going to be about 8 by 8 by 8 inches. If you had a part that's bigger than that, you would need to either split it into multiple components or scale it down. It all depends on what you're trying to do. And you can definitely use step files for printing. I don't know, I think that Peter, you also mentioned that you can both import and export step files to the platform.
Yes, for sure. Yeah, absolutely. You can convert those to STL. Yeah. And you can work with those files even on the go if you do not wish to sit in the office all day long, or if you travel a lot, let's say. Yeah, it's up to you.
And then, one other question that I had specifically as I saw you interacting with the interface, what would you recommend for somebody who's just getting started between using directly the Apple Pencil versus like a direct input, like selecting, the numbers or typing in the dimensions? What are your sort of your best tricks and
in the old days, back in the old days, we all created drawings by hand on a paper, and interacting with a pencil is much more natural than interacting with a keyboard and a mouse. It is like a barrier when you are modeling, and if you can interact directly on the touch interface with the pencil, it feels like there is nothing between the design and you. It feels like much more natural, I think.
Yeah, I guess that was also my first impression with it. And now that you mention it, it's like a lot like sketching, but you usually assume that sketching is only going to be 2D. So as soon as you start jumping and seeing that you can sketch in 3D, that makes it very, very powerful. Another question on the bandwidth itself. So are there any bandwidth limitations? Essentially, what type of connection do you need to have, and any sort of concerns on, or again, best practices for you to connect to the Shaper 3D service?
Technically, Shaper 3D is running offline on the iPad or even on your Mac, so you don't need to have active connection while you are modeling. You will have to have any connection to sign into your account and to be verified, but during the modeling process, it is perfectly fine if you don't have active internet connection, because let's say you are on the train or you are on an airplane.
Okay, that's good to know. Another question on the model itself: how do you change the reference or origin point of the 3D body? So before exporting,
you can simply just move the body away. Like we have one origin point in the workspace, and each body is oriented around it, like in a multi-body model workspace. And if you wish to move the models away, you can simply just select those somehow by double tapping on the pencil or with the lasso, as you could see in the presentation, and you can move them away. Currently, it is not possible to redefine the origin of the whole workspace.
Yeah. I guess that also connects to the origin as you export the file, because we have one question specifically on, well, how do you specify where to use support materials? And I'm assuming during the printing process. So I'll go ahead and bring you guys back to the interface so that you can see once more the, sort of support generation process, and connected to, like, I'll just hit start a new print here. Bring again your file, Peter. And while I'll say so, like the origin itself, especially after the file has been exported, it's fairly straightforward to change here. As you can see, now the origin access points is kind of reset, and it's now unique to the part itself. It's actually taking the bounding box of the part and putting the corner or the origin point of this body in one of the corners of the bounding box. In this case, I'll just rotate my part a little bit so that it can fit nicely in my build plate. There we go. And going to that specific section, a specific question, sorry, on the support type, you can use different types of support. So Breakaway is going to be printing your supports with the same material that your part is made up of. Then Dissolvable Column is going to essentially create, let's say, a projection of your part straight down into the build plate. Pretty kind of sort of I would say, constrained type of support generation. Dissolvable, which is the default setting that we're going, sorry, tapered is the default setting that we usually use, essentially creates not quite a projection, but sort of like a thinning pyramid of sorts that will, be generating upwards until your part and trying to decrease the amount of support needed as you progress, in height on the part. And finally, you can use also breakaway as support material. What that means, and I'll show you how does that look like. But what that means is that the breakaway supports are a little bit of a zigzagging line. So it's a thinner type of support. And it's going to be probably faster for you to remove it and also for you to wash it away, just because it has a more exposed surface area. The software itself is smart enough to generate or self-generate the support where it needs to, right? So you don't need to really do anything to actually define where this support is needed. It's just going to take your part and make sure that it prints successfully regardless of the orientation, right? So there's no real input necessary from the user when generating the supports, because it's going to actually, the slicer does that automatically for you. Let me jump back here to our Q&A document. And well, yeah, this is a good question. Do you have any special prices for schools and universities for Shaper specifically?
We have an educational program. If you're a student or if you're a teacher, then you can apply for a free annual subscription that you can renew every year until you leave the educational institution that you're in. There is a form that you can fill in the app on our pricing page, and you will be upgraded in a few days after you submit your query.
Nice. Another question on the app itself. So when converting into a print-ready mesh model, is there like a detailing scale for polygon resolution when exporting to a mesh-based model?
Yeah, sure. We have low quality mesh export for the free license. We have high quality mesh export with the paid tiers, and there is a custom setting available for both licenses, for both paid licenses, that lets you adjust the distance deviation and the angular deviation of the files. So you can refine the polygonal result of the exported files.
Okay.
It is possible to do that.
Another question on like jumping from other CAD software. So if you're coming to Shaper from another CAD program like SolidWorks, what is the learning curve like?
Really depends on the users, but as we see, our users are surprised how easy and how fast to get used to Shaper 3D. It's like sitting down and drawing on the paper, and the result is a 3D model. So I would say it's pretty fast.
Yeah, I think I would agree with that, especially like myself. I was coming from, basically my main pieces of software used to be SolidWorks, Rhino, and Fusion 360. All of them, as you were describing before, are very much mouse-based, right? So once you know like the types of tools, the types of modeling that you want to do, it's very straightforward to jump in. And as you were saying, like sort of, I think it's important for you guys to test it out and feel it yourself, experience it yourselves, because it's just like drawing. It's hard to describe because before you do it, you don't really, it's hard to imagine how easy can it be. But you're essentially just creating the shapes, and the app is kind of reacting to your movements in a very natural way. So yeah, I would say that anybody with even little experience on any modeling software, and even somebody who's new to modeling itself, can just get a pen and start designing and create a shape with it. So I would definitely highly recommend people to just download the app and try it out, because it's impressive how fast and easy it is, even if you're using a completely different setup, but it's a more intuitive one. So that's kind of like the big balance I see in Shaper. Let's see. I think is MakerBot planning to make a version that includes subtractive manufacturing processes that utilizes a spindle for trimming and finish and manufacturing machining in the future. Not at the moment. We're very much just heavily concentrated on 3D printing, so only additive. And that's where all of our efforts is coming into. So we're definitely focused on that space. And with that, I'm going to start closing it up. Thank you guys, Esteban, and thank you so much, Peter, for joining us today. I don't know if you guys want to give us a few last, lines and quotes from your guys' end. I'll remind everybody in the audience about the promo that Esteban very kindly announced here. So 30% off with that that code MakerBot10. Definitely, highly recommend if you guys are interested and curious to go and check it out. But I'll let you guys, wrap things up from your end.
Thanks, Felipe, for having us. It was a pleasure to be here, and we are really excited to see what MakerBot users are going to do with Shipware 3D. Thanks for having us.
Well, with that, thank you so much. If you guys have any more questions, be sure to send them out to hello@makerbot.com. We'll be watching that email closely, and we'll make sure to forward those to both Esteban and Peter. Any questions, just let us know. And as always, thank you guys so much for watching us, and keep watching the next sessions of our Pro Summit. And thank you, Esteban, and thank you, Peter. Have a good day.